Hello everyone. Today we'll be looking at a GATE 2022 chemical engineering question number 49. For a pure substance, the following data at saturated conditions are given. So the Ln of P saturation is given as 0.693 at 350 Kelvin and 1.386 at 370 Kelvin. Assume that the vapor phase behaves ideally. The molar volume of the liquid is negligible and latent heat of vaporization is constant over the given temperature range. The universal gas constant R is given as 8.314 joule per Kelvin per mole. From the above data, we have to find the estimated latent heat of vaporization at 360 Kelvin in kilojoules per mole rounded off to 1 decimal place. So we can solve this by using the Clausius-Clapeyron equation. And this is relatively a straightforward thermodynamic question. So this is basically direct substitution. So one of the forms of Clausius-Clapeyron equation is given as ln P2 by P1 is equal to delta H by R the whole into 1 by T1 minus 1 by T2. So our aim here is to find delta H, which is the latent heat of vaporization. So from the equation, the pressures P2 and P1, both of these are given in their logarithmic forms as ln P saturation. The temperatures in the question, T1 is given as 350 Kelvin and T2 is given as 370 Kelvin. The pressures, the saturation pressures ln P1 sat is given as 0.693 and ln P2 sat is given as 1.386. So this is just a direct substitution of the given values. So we can rewrite the Clausius-Clapeyron equation. So ln P2 by P1, or rather ln P2 saturation by P1 saturation is equal to ln P2 saturation minus ln P1 saturation. And this is equal to the right hand side, which is delta H by R the whole into 1 by T1 minus T2. Now we just have to substitute the values which we have. So here ln P2 sat is 1.386 minus ln P1 sat, which is 0.693, is equal to delta H by R, and R is given as 8.314 the whole into 1 by T1, and T1 is equal to 350 Kelvin minus 1 by T2, which is 1 by 370 Kelvin. Now doing the mathematical operations and rearranging this equation, we can get the final answer, which is delta H is equal to 37.306 kilojoule per mole.